Hey there, boys and girls and children of all ages. So today we are going to identify types of functions from a table. Basically, we're going to ask, is it a linear function, quadratic function, or exponential function? We've already talked about the actual equations in class, what the graphs look like, but today we're going to actually discuss what the tables look like and what differentiates the different types of functions. So let's lead off with linear functions. And we have a couple examples here. And what we're going to do is we're going to go through and see what makes it a linear function. So we have a data table. We have all of our inputs and all of our outputs that we've plugged into some equation that's obviously linear. But in this case, we're not given the equation. We're just given the data table. So we want to look at the different outputs. The inputs pretty much stay the same. If I go down the inputs, if you notice when I go from one input to the next, I'm basically adding one every single time. And that's pretty consistent. Nothing changes here. However, on the outputs, if I go over here and I see the difference of them, how much it actually changes. This is going to go up by 2, and that goes up by 2. That will also go up by 2. And that will go up by 2. So what makes something linear is we have a constant change or a constant rate of change. So every time we go up 1, we're going up by 2 every single time. So if something's linear, it means that the initial change, the first change, all right, our initial change is going to remain constant and the same. So we're going to either add or subtract the same number every single time. Let's look at another example. So over here, just to change up the colors a little bit, we're going to go up 3. We also go up 3, and we go up 3 again. Now let's look at the actual outputs. And see that this is a constant change, the very first difference or change. So here, we're going to go down 1, from 4 to 3. From 3 to 2, we're going down 1. And from 2 to 1, we're going down 1. So once again, if you notice at the outputs, it's basically going to be a constant or the same change over and over and over again the first time through. And you're either going to be adding or subtracting. So here we're adding, here we're subtracting. All right, so that's what linear functions do. It's the same change the first time through. Let's take a look at quadratics. So, quadratics. And don't forget, if you're watching this video from my class, because maybe you missed that day, you can feel free to hit pause, write down the data tables, and then hit play again and find out what I'm talking about. All right, so this next one. Once again, the inputs don't only change by 1. They're only changing by 1 on both. So let's look at the outputs and see what's happening there. So the outputs. Here, and the first difference here is we're going to go down by 1. And then here, we're going to go up by 1. So right away, it's something different from before, because before, we had the same rate of change all up and down our table. Here, I'm going to go up 3. And here, I'm going to go up 5. Remember, all this is just the same. We're just going up 1 on the inputs. So immediately you're looking at this going, well, it's not linear because this is not constant. It's not the same change. We're not adding or subtracting the same thing over and over again. What you want to do with quadratics, and the next thing you want to check is, we're going to check the rate of change from the change, or the change of the change.
Attention to any staff still in the building. This is just a reminder, if you would like the flu shot, Ms. Miller, our nurse, is in the main.
If you guys want a flu shot, now's your time to get a flu shot. All right, so the difference here is going to be, when we go from -1 to +1, we're actually going up 2. We go from 1 to 3, we're also going up 2. And lo and behold, we're going to go up 2 the second time. That's what makes it a quadratic. It's the change of the change that makes it, that if that's constant, that's what makes it a quadratic. Like watch, you're going to notice the same thing on this side as well. And we're either going to be adding or subtracting on these. So let's go down and let's see the change. So here, we're actually going up 3. We're going up 5. Up 7. And up 9. Once again, even though I'm adding every single time, I'm not adding the same number over and over. So it's not linear. So now I'm going to check for the change of the change, or the second difference. Because the red would be the first difference, and the blue is going to be the second difference. If I notice, the change changes by the same rate every single time. And that's what's going to make it a quadratic function. So if we were to graph this, we'd get like that nice little parabola. And if we were actually to figure out whatever the equation was, we'd have an x squared on there, which would also make it a quadratic. All right, so for quadratics, we check out the change of the change. And if that's consistent by adding or subtracting, then we know it's a quadratic. Last but not least, exponential. Obviously, this is going to be a little different. And no, we're not going to do the change of the change of the change of the change of the change. But there is a pattern here. That's really what math is all about, looking for patterns. All right, so initially, if we're attacking this and we don't know it's exponential, we might initially look at this and go, okay, I'm going to add 2. And then we might go, okay, I'm going to add 4. And then I'm going to add 8. And you might be thinking, okay, well, it's not linear. Maybe it's quadratic. So we'll check for that. Okay, well, I might add 2 every single time, but wait a minute. I'm not adding 2 every single time, so it's not quadratic. It has to be something else. Can we find another pattern here? All right. We want to go from 2 up to 4. Obviously, we can add 2. But what else can we do to go from 2 up to 4? That's right. We can multiply by 2. So if I multiply that by 2, let me see if I have that pattern. And 4 times 2 would be 8. 8 times 2 would be 16. So exponential is when the actual change happens, but you're multiplying instead of adding or subtracting. So you're actually multiplying by this. And it's actually a ratio of, on this side, you're still going to add 1 on both sides. Or you'll still be adding and subtracting on both sides over here. But the ratio, so every time we add 1, we're multiplying by 2. Add 1, multiplying by 2 more. So that's really what makes it exponential. So even over here, we're going to be adding 1 every single time. However, now we're going to go over to see if we multiply these out. So yeah, I'm not going to add 12 every single time. So if I was adding 12 every single time, then it'll be linear. If the change was the same every single time, then it'd be quadratic. But here, to go from 6 to 18, we're going to multiply by 3. One of the easier ways to do that is to take your second number divided by the first number. So 18 divided by 6 would be 3, which means we're multiplying by 3 every single time. And to kind of check it out, also check out 54 divided by 18. You should also get 3. 162 divided by 54. In your handy-dandy calculator, you're also multiplying by 3. So with exponential, the initial change, if you're multiplying, or multiplying by negative, it could be work out that way, then that's what makes it exponential. All right? Real quick recap. Linears. The change is going to remain constant. You're either adding or subtracting. Quadratics. It's the change of the change which makes it a quadratic. And then finally, oh, wrong one. Exponential, you're checking out the change, but here you're multiplying instead of adding and subtracting. All right, if you have any questions, please leave me a comment or please ask me in class. Until then, I'll see you next time.